So today's question is to explain hydrolysis. So when we have acids and bases, they react to form salt and water, and that's called hydrolyzation reaction. Yay, it didn't disappear. I'm so happy. We'll get to the strong base one. So we expect with neutralization, we expect the pH of the solution to be 7 as neutralization. But some of the reactions will not yield a pH of 7. It yields an acidic solution. Where? When strong acid reacting with a weak base, the salt that is formed during that neutralization reaction will react with the water. There will be lots of water in the solution because usually the acid and the base is a solution in water. And then water is formed as well. So one of the ions will react with the water, and that is what is called hydrolysis. Your textbook has a definition for hydrolysis. What does it say? Either the cation or the anion of the salt that is formed during the neutralization reacts with water to increase the oxonium ion concentration or to increase the hydroxide ion concentration. Yes.
And the anions may react with water molecules forming OH.
I say, that is it. Yes. So cations of the salts will form oxonium ions, anions of the salts will form hydroxides. So let's look at an example. Give me an example of a strong acid. HCl. So your strong acids are the HCl's, the HNO3s, and the H2SO4s. Those are the three very strong acids. Give me an example of a weak or a moderate base. Okay, you've got a table in your book that's got these things. It's got Ka and Kb. NaOH is a very strong base. Some people tasted that. NH3. So NH3. This is a weak base. That is a strong acid. What is the salt that will form in this reaction? NH4. That is the cation formed, and the anion formed will be Cl negative. Now we had a container of ammonia and a container of hydrogen chloride, and the gases that came out of the containers made white clouds. We saw white clouds. Are you right? All right with that? That was the ammonium chloride. It's actually a salt. So I can say ammonium chloride. This reaction is a reversible reaction. Can you remember that? Okay, so I can also say that this arrow goes that way and it can go that way. So it is a reversible reaction. Now if this happens between the solutions, these ions will be separated. So this would be NH4 like I wrote it before, plus dissolved in water and Cl negative. Now the anion that comes from the strong acid can't undergo hydrolysis. This one comes from a strong acid. So no hydrolysis. It can't react with the water. But this one comes from a weak base. This is formed, it comes from a weak base. This weak base forms a what? What would this be? Strong conjugate base. And what is a base?
Ma'am, like which one? Like a Lowry Bronsted or the Arrhenius?
Good question. Lowry Bronsted. It's a strong proton donor. So who will take this proton? The water will take the proton. Okay.
Please can you please repeat why the strong acids cannot undergo the hydrolysis?
It's a miracle of creation. It doesn't happen. It's a weak base. If you feel weak, you can't do any work. You can't do any fighting. Is it making sense if I say it that way?
What's the point of we're talking about hydrolysis right now.
Wait, I'm getting there. I'm just getting there slowly. I'm trying to work from basics. When a strong acid reacts with a weak base, hydrolysis of the salt, actually the cation that is formed, will take place. So I'm still getting to the hydrolysis. I'm trying to explain why hydrolysis will take place. Because a weak base will form a strong conjugate. Sorry, I made a mistake here. This is a strong conjugate acid. Yo. And an acid is a proton donor. No, the proton donor is right. My writing there, base, was wrong. So what will a strong conjugate acid do? It will want to donate its proton. Where the chloride ion, the question was why won't the chloride ion undergo hydrolysis? The chloride ion is a weak base. I got that right. So a strong acid, the HCl, will form a weak conjugate base. I need to go on. Can I go to the next slide? So now we've got this ammonium ion in the presence of water, and it is a strong acid, and when it donates its proton to the water, it will form H3O+, and according to Arrhenius, this makes the solution acidic. So we'll revert back to ammonia that will be formed. So this formation of this so the pH will be less than 7.
So ma'am, the water is acting as a weak base.
Water is acting as a base, yes.
Just a base, not a weak
Yes, but this reaction is the hydrolysis. So we've got more. We have met up with more than one type of hydrolysis reaction. In organic chemistry, we've got hydrolysis, and in acids bases, we've got hydrolysis.
The previous reaction is not a hydrolysis.
No, the previous reaction was a neutralization reaction. So the next example is a weak acid. Now any organic acid is a weak acid. Anything, citric acid, ethanoic acid, oxalic acid, and a strong base. It will also form a salt and water. But here the anion formed will react with, it will be a weak, whatever, weak, the anion, so it's a weak base, am I right? Then it will react with the acid. So let's see, yes?
CO3.
CO,
3. 2 negative.
what, CH?
CO3.
CO3.
Yes.
Carbonic acid. Yes, carbonic acid is a weak acid. Yes, and no, not there yet. Strong base. NaOH. Any group 1 hydroxide, lithium hydroxide, sodium hydroxide, potassium hydroxide would be strong bases. Yes.
So now basically our hydrolysis reaction, what makes it is the neutralization reaction. Without neutralization,
Yes, the salt formed during the neutralization. Yes. The salt that will be formed here would be sodium carbonate. Am I right? And water. Okay. Now, sorry, I didn't balance this. Let's balance it for those people who need it balanced. Okay. So they expected originally that during neutralization the pH of the salt solution will be 7, but it's not 7 because this is a weak acid. Now, which part here is the strong conjugate base? Which part? It's not the Na2CO3, it is just the CO3 2 negative. The strong conjugate base here is the CO3 2 negative. So what will it be? What will it do? It will grab something from the water. Because it's so strong, it doesn't want to be alone. So the hydrolysis reaction is the reaction between the strong conjugate base and water. And this strong conjugate base is usually an anion.
It's a strong conjugate base, the salt.
No, it's part of the salt.
Part
Yes. When you had a weak acid and a strong base, it is the anion in the salt. When you have a strong acid and a weak base, it's the cation in the salt. So, this is the hydrolysis reaction. CO3 2 negative plus H2O, and it's also a reversible reaction. It makes HCO3 negative and OH negative. So who's the acid here? The acid is the water.
Is the neutralization also a reversible reaction?
Pardon?
Is neutralization also a
No, not always. No. No, it's not. And because of the OH negative, the increase in the concentration of the OH negative in solution makes the pH higher than 7. And then you need to know as well which indicators would be suitable indicators for the neutralization reactions. So when we did oxalic acid last term, oxalic acid and sodium hydroxide, we didn't choose litmus as an indicator. We chose phenolphthalein as an indicator. It's because phenolphthalein, phenolphthalein is the indicator that will be accurate, will give you an accurate reading. Because something like litmus will change color at a pH of 7. But this one changes color at a higher pH. And what is a suitable indicator for the strong acid, weak base? Which one? Methyl orange. Let me check. Methyl orange. Yes, you're sharp. Oh, I love you. Methyl orange.
So phenolphthalein is good for strong acid, for
weak acid,
weak
strong
acid.
base.
So remember, this is the only indicator that we must learn. Because under acid and base.
I can't say that because in your textbook there is a list of indicators. So the more common indicators is litmus, you know, from primary school. It changes color at a pH of 7. And the red-blue story. Bromothiamyl blue is one that they use more often in laboratories. Changes from yellow in acid to blue in base, also at pH 7. Methyl orange, red and yellow, changes between 3 and 4, pH 3 and 4. And then universal phenolphthalein changes between 9 and 10. And then universal indicator you can, you need to know all those. Yeah. So pH basically comes from the ionization of water. Water naturally ionizes. It breaks up to form H plus and OH negative. Naturally. Water is a liquid. Hydrogen is the AQ. Hydroxide is AQ. So at 25 degrees Celsius, they found that the concentration of the hydrogen ions there is 10 to the power minus 7. It's a 10 millionth of a mole per cubic decimeter. And the concentration of the hydroxide, guess what it would be? Why? Because 1 mole there forms 1 mole there. For every 1 hydrogen ion, there will be 1 hydroxide ion. They ionize in the ratio 1 to 1. Okay, so it will be 10 to the negative 7 mole per cubic decimeter. So what is, I want to write Kc, but I know I must write Kw now. What is the expression for Kw? Concentration of H plus, OH negative. Must I divide by the concentration of water?
No.
Why not? Because it's a liquid, so we don't do that. And that is where 10 to the power minus 14 comes from. Is there a lot of hydrogen ions or hydroxide ions in water? Definitely not. Why? Because this thing is very much smaller than 1. Do I need to do pH calculations again? The Kw for water is fixed. It stays 10 to the minus 14. Doesn't change. They always work at room temperature. If the question is not for a situation at room temperature, they have to give you the Kw value that they want you to use. Okay? Did you hear what I'm saying? Good. Can I use a diprotic acid? Do you know what a diprotic acid is?
It can use
2 hydrogens, 2 protons. Okay? So I'm going to use sulfuric acid. You can choose what the concentration of the sulfuric acid is. If somebody wants to choose. What? 0.5. Can I move? So we've got sulfuric acid in our example, and the concentration of the sulfuric acid is 0.5 mole per cubic decimeter. I want us to calculate the pH of that solution. Can I go? So we've got sulfuric acid, H2SO4, and the concentration of this solution is 0.5 mole per cubic decimeter. Okay, and I want us to calculate the pH of the solution. Now this acid is mixed with water, so it is an aqueous solution. The water's Kw is 10 to the minus 14. That is it. Okay. What is the concentration of the hydrogen ion, or some people like to use the concentration of the oxonium ion? It's referring to the same thing. What is the concentration of the ion in that solution? Now for 1 mole of sulfuric acid, how many moles of oxonium will we have? 2 moles of oxonium or hydrogen or protons. Are you with me? Okay. Now, concentration is directly proportional to moles because concentration is calculated by taking moles and dividing it by volume. So the volume of the acid and the volume of the hydrogen ions exactly the same. So if the sulfuric acid has that concentration, 0.5 mole per cubic decimeter, what is the concentration of the hydrogens or the oxoniums then? 1 mole per cubic decimeter. What will the pH then be? Okay, so what is the concentration of the hydrogen concentration? It is 1, nah? And how much of it comes from water? 10 to the minus 7. What's 1 plus 10 put to the minus 7 actually? It's 1, comma 0.0000001. So what happens to that contribution of hydrogen ions from the water? It's negligible. We can ignore it. So pH is negative log concentration hydrogen equals negative log 1. What is that? 0. You. All right. Let's calculate pOH. Okay, pOH. Okay, pH and pOH would be what? 14. Because the concentration of hydrogen ions times the concentration of hydroxide ions is 10 to the minus 14. Now logs and multiplication works this way. If you multiply the numbers of the concentrations, you add the pHs and the pOHs to get 14. Right, choose. What is the concentration? Choose a base. NaOH is the favorite base. And what is the concentration of your base? Don't go for 0.5. Oh yeah, you can go for 0.5 if you want to. What is the concentration that you would like to use? Choose a different number. 1.2. 1.2 times 10 to the minus 3. No, don't go too small now. Okay, minus 3 mole per cubic decimeter. What is the pOH of this? Negative log 1.2 times 10 to the minus 3. Go for it on your Casios.
You don't take the negative.
Yes, negative 10 to the power, negative log 1.2 times 10 to the negative 3.
2.92.
2.92 is the pOH. What's the pH? What is the pH if the pOH is 2.92? Yes. Then we go to this equation. pH plus pOH equals 14. If pH, we say 14 minus 2.92. We minus the pOH. Okay, so that is 11,08.
And the solution is basic.
This solution is basic, yes.
Now, you always assume that it's aqueous.
Yeah, they work in aqueous medium, yeah. Neutralization reactions takes place in water.